When considering temporary power for sheds with damp conditions and open walls, several factors need careful consideration. The primary options are installing a subpanel or running additional branch circuits from the main building. Due to the moisture and openings in the sheds, there are significant safety risks associated with any electrical installation. Damp conditions greatly increase the risk of electrical shocks and fires, making it imperative to implement robust safety measures. Because the subpanel will only be used temporarily for about 1 year, the cost of installing and then removing it may not be a justified expense. It's also crucial to consider long-term solutions like waterproofing the sheds or incorporating a new electrical system when the replacement sheds are built. Installing additional branch circuits from the main building could be a safer and more cost-effective alternative to installing a subpanel. However, several factors remain. Firstly, the wire size and insulation must be appropriate for the electrical load in the harsh environmental conditions, including moisture and cold. Secondly, all connections and outlets must be protected from moisture and corrosion to prevent electrical malfunctions. Thirdly, circuit breakers or fuses must be installed to protect the circuits from overloads and short circuits, ensuring a safe and reliable electrical supply. Given the safety concerns and the temporary nature of the power solution, opting for additional branch circuits from the main building is generally recommended. A qualified electrician should thoroughly assess the conditions and install the circuits in a safe and code-compliant manner. It is crucial to ensure that all work complies with the National Electrical Code, or NEC, and local electrical codes. Furthermore, post clear signage and warnings alerting people to the presence of electrical hazards in the damp and open sheds. This will help prevent accidents and ensure that anyone working in or around the sheds is aware of the potential risks. Regularly inspect the electrical installations and perform necessary maintenance to ensure continued safety. This includes checking for any signs of corrosion, damage, or wear and tear, and promptly addressing any issues that are found. For example, if any outlets or connections are showing signs of moisture damage, they should be replaced immediately. When dealing with electrical installations in damp or wet locations, it's important to use appropriate wiring methods and materials. According to the NEC, several types of wiring are suitable for wet locations. Firstly, type UF cable or underground feeder cable is designed for direct burial in the earth and is also suitable for use in wet locations. Secondly, type THWN or THHN wire installed in conduit is another option. THWN wire is moisture resistant, while THHN wire is heat resistant. When used in conduit, these wires are protected from physical damage and moisture. Thirdly, type XHHW wire is a cross-linked polyethylene insulated wire that is moisture and heat resistant. It is suitable for use in wet and dry locations. Ensure that all electrical boxes, fittings, and enclosures used in the sheds are rated for wet locations. These enclosures are designed to prevent water from entering and damaging the electrical components. Some common types of wet location enclosures include firstly, weatherproof boxes, which are designed to protect electrical components from rain, snow, and ice. Secondly, watertight boxes, which provide a higher level of protection and are suitable for use in areas that are subject to submersion. Thirdly, conduit bodies, which are used to make bends and connections and conduit runs while maintaining a weatherproof seal. Ground fault circuit interrupters, or GFCIs, are essential for protecting people from electrical shock in wet locations. GFCIs are designed to detect even small amounts of current leakage to ground and quickly trip the circuit, preventing a dangerous shock. All outlets and circuits that are likely to be used by personnel in the shed should be GFCI protected. This includes outlets for power tools, lighting, and other equipment. Proper grounding is also critical for electrical safety. The grounding system provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and to energize the circuit. Ensure that the grounding system is properly installed and maintained. This includes grounding electrodes, grounding conductors, and bonding connections. Electrical inspections are an important part of ensuring electrical safety in compliance with codes and regulations. A qualified electrical inspector can identify potential hazards and ensure that the electrical installation meets all applicable requirements. Schedule an electrical inspection after the installation of the branch circuits to verify that the work has been done correctly and safely. When selecting an electrician for this project, it's important to choose someone who is licensed and experienced in electrical work. Ask for references and check online reviews to get an idea of the electrician's reputation and quality of work. A licensed electrician will be familiar with the NEC and local electrical codes and will be able to ensure that the installation is done in a safe and code-compliant manner. They should also be able to provide you with documentation of the work that has been done, including permits and inspection reports. If the existing electrical panel in the main building is not large enough to accommodate the additional branch circuits, it may be necessary to upgrade the panel. An electrician can assess the electrical load and determine whether a panel upgrade is needed. Upgrading the panel may involve replacing the existing panel with a larger one or adding a subpanel to provide additional circuit capacity. The wire size for the branch circuits will depend on the amount of current that the circuits will be carrying. The NEC specifies the minimum wire size for different amperage ratings. It's important to choose the correct wire size to prevent overheating and potential fire hazards. For example, a 15 amp circuit typically requires 14 American wire gauge or AUG copper wire, while a 20 amp circuit typically requires 12 AWG copper wire. When running the branch circuits from the main building to the sheds, it's important to protect the wires from physical damage. This can be done by running the wires in conduit or using armored cable. Conduit provides a higher level of protection than armored cable and is recommended for areas where the wires are likely to be exposed to physical damage. The type of conduit used should be appropriate for the environment. For example, PVC conduit is suitable for underground installations, while rigid metal conduit is suitable for areas where the conduit is likely to be exposed to physical damage. Proper labeling of electrical panels and circuits is essential for safety and troubleshooting. All circuits should be clearly labeled with their purpose and the area that they serve. This will help prevent confusion and make it easier to identify and correct any electrical problems. The labeling should be durable and resistant to fading or damage from moisture or other environmental factors. Regularly test the GFCIs in the sheds to ensure that they are functioning properly. GFCI should be tested monthly by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Electrical safety is an ongoing process, and it's important to stay informed about potential hazards and best practices. Attend electrical safety training courses and read articles and publications on electrical safety. This will help you stay up to date on the latest codes and regulations and learn how to identify and prevent electrical hazards. Consider installing surge protection devices to protect sensitive electronic equipment from voltage spikes. Surge protection devices can help prevent damage to computers, power tools, and other electronic equipment caused by lightning strikes or other electrical surges. Surge protection devices are available in a variety of forms, including whole-house surge protectors and plug-in surge protectors. Be aware of the potential for arc flash hazards when working with electrical equipment. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. Wear appropriate personal protective equipment, or PPE, such as arc-rated clothing and face shields, when working on or near energized electrical equipment. Maintain a safe distance from overhead power lines. Overhead power lines can carry thousands of volts of electricity, and contact with these lines can be fatal. Keep ladders, poles, and other equipment away from overhead power lines. Before digging underground, always call 811 to have underground utilities located. Digging without knowing the location of underground utilities can result in damage to electrical lines, gas lines, and other utilities, which can be dangerous and costly. Always follow lockout-tagout procedures when working on electrical equipment. Lockout-tagout procedures are designed to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the power supply to the equipment and placing a lock and tag on the disconnect switch to prevent it from being turned on. Be aware of the potential for carbon monoxide poisoning from generators. Generators produce carbon monoxide, a colorless and odorless gas that can be deadly. Never operate a generator indoors or in an enclosed space. Operate the generator outdoors in a well-ventilated area away from windows and doors. Have a qualified electrician inspect the generator and electrical system before using it. The electrician should ensure that the generator is properly grounded and that the electrical system is capable of handling the load of the generator. Use extension cords safely. Extension cords should be used only temporarily and should be of the proper gauge for the equipment being powered. Do not overload extension cords or run them under rugs or furniture. Inspect extension cords regularly for damage and replace them if they are frayed or damaged. Never use electrical equipment near water. Water conducts electricity, and using electrical equipment near water can create a serious shock hazard. Keep electrical equipment away from sinks, showers, and other sources of water. If electrical equipment gets wet, unplug it immediately and do not use it until it has been inspected by a qualified electrician. Report any electrical hazards to the appropriate authorities. If you see a downed power line or other electrical hazard, report it to the utility company or local authorities immediately. Do not attempt to repair the hazard yourself. Keep trees and shrubs trimmed away from power lines. Trees and shrubs that grow too close to power lines can create a fire hazard or cause a power outage. Contact the utility company to have trees and shrubs trimmed away from power lines. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. A qualified electrician can answer your questions and provide guidance on how to stay safe around electricity. They can also perform electrical inspections and repairs to ensure that your electrical system is safe and up to code. Remember that electricity is a powerful force that can be dangerous if not handled properly. By following these electrical safety tips, you can protect yourself and your family from electrical hazards. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns.